Question 10, and it's another proportion question. This time it's asking about the how the gravitational force changes when we're messing around with masses and distances. So again, let's remind ourselves of the equation of gravitational force relating to masses and distances. It's going to be G mm over r squared. There goes a fly. So we're told, first of all, and we'll put this to the side, by the way, because we're going to be using f for a very particular. Whoa, hello fly. Dear me. Did not like that lamp. We're going to be using f for a very particular situation. We're going to say that f is the force when we have an object of m and 2m as the masses. So m and 2m are the masses, and they are a distance between them of r. So I've got to work out what my new force is going to be if I'm going to use now, we've got 2m and 4m, haven't we? 2m, 4m, and now we've also changed the distance to 4r. So we've got to work out what's going to happen to the force, and again, just literally by go away fly, you are not wanted here. Literally by looking at what's going to happen with these things, we can work out exactly what's going to happen to the force. So the force is proportional to the product of the two masses that are involved. Initially it was m and 2m. That would give us, say, a product of m times 2m, which would give us 2m. Whoa, bad m, 2m squared. But now we're moving to a system where we've got 2m and 4m. 2m times 4m is going to give us 8m squared. So we're going from the product of masses going from 2m squared to 8m squared. That's an increase fourfold, isn't it? That's 4 times as big as it used to be. So from that factor alone, just by changing the masses, the force will now be 4 times as big. So the force will be going to 4F from that one. But that, of course, is not the whole story. Just drawn on the desk. The other thing we're doing is we're changing the distance rather. We're now becoming 4r instead of r. So if I take r squared and I turn that into 4r all squared, well, 4r, how exciting an email. 4r all squared is going to give me 16r squared. So it's gone from r squared to 16r squared, so now this factor, changing the radius, is giving me a factor of 16 down here. So the force now is going from F to 16th F. F over 16. And those are the only two things that are changing. So I've got my changing masses, which are going to give me 4 times as much force, but my changing distances will give me a 16th as much force. Combine those two together, it's going to times by 4 divided by 16. That's the same as just a quarter, isn't it? So we're going to end up with a quarter F. So the answer to 10 is going to be A, 0.25 F.